Okay, this is Calculus 8. We're looking at optimization. And I think I'm just going to start off with explaining the first example in Mr. Autry's notes here. There's a farmer, and he wishes to make a rectangular field using 200 meters of fencing. One side of the fence is against an existing wall, so he doesn't have to use that part. So there's no fencing is needed there. There's a 2-meter wide gate that's required. So here's the deal. There's 200 plus the gate, that's 202 meters. It's going to make a rectangle, but there's two things you don't know. First, it's good to draw a diagram of a situation like this. There are two things you don't know. You don't know the width of this rectangle, and you don't know the length. Well, if you let the length be x and the width be y, then you could come up with a formula for the area, x times y. You kind of have to make equations like that. There's the next part is you need an equation just in one variable. We've got that the area is equal to x times y. We want to maximize that area, but we need to get y in terms of x. And here's how we might do that, okay? We've got that x plus 2y equals 202. If we take the length and the two widths, y and y, if we add them together, we get 202. If we now we just make y the subject, we subtract x, and then we divide by 2, we get y equals 101 minus a half x. And then we have these good notes here that kind of explain that this is a key part here, because we've got to get y in terms of x so we can get the area just in terms of x. So we go back to the area equation, x times y, that is the length times the width gives us the area. All we do is we rub out the y and we put in 101 minus a half x. So that's what's happened here. Then we multiply it out. X times 101 is 101x. X times minus a half x is minus a half x squared. Well, there's the equation of the area. We know that it's x squared. It's a parabola. And it's got a negative here, so it's an unhappy parabola. But our problem is we want to get find the x value that's going to maximize the area. Well, what we're really looking for is the top of this parabola, the maximum part of it. And we know we can do our calculus thing. All we do is find the derivative of this. So we go through, take the derivative. 2 times a half is negative 1. 101x, the derivative, that's just 101. There's the derivative. And we know to find a maximum, you let the derivative equal 0. So x equals 101 is the answer. We just go 101 minus x equals 0. So if x equals 101 meters, that's going to give us the maximum area. And if we put it back into the original, into our equation for the area, we'll get what that maximum area would be. And in the notes here, they've made a nice parabola here. I think they graphed this parabola, and you can see there's where the maximum would be when x is equal to 101. So it should be right at the top. Well, hopefully this video helped a bit. And I'm going to do a video of the next section too, of the next example.